Hi-oh, here we are again. Electrostatics. We're going to focus on the very basics, the things, the fundamentals that you need to know in order to do anything dealing with electrostatics. First off, we have the definition. Pretty important to know what exactly we're talking about here. Electrostatics is basically electricity that's not moving. It's static. So this isn't the kind that goes through your outlets. This is the kind that builds up on you, and when you go to grab the doorknob, you get shocked. In order to really talk about this in any great detail, we have to talk about the very basics of where the charge comes from. We'll start with atoms. The atoms, I think you'll remember from 6th grade, have negative and positive charges. The negative charges are those electrons, and the positive charges are the protons, which are contained within. It's a pretty important idea to realize the only thing that moves, I can't emphasize this enough, the only thing that moves are those electrons. They're loosely held and they can be removed from the atom. The protons can't. If you remove a proton, you've completely changed what substance you have. If you have, for example, helium, which has 2 protons, if you get rid of 1 proton, you now have hydrogen. So things don't work out well to do that. But electrons are okay. We can do that. So think about what's going on. If we can move electrons, and atoms are basically neutral to begin with, and let's say we remove an electron, we have less electrons than we have protons. So it becomes positively charged. We have too few electrons. What if we were to add an electron? Well, we would have extra electrons, and the object becomes negatively charged. So the key factors here are only electrons move, and based on if you have more or less electrons, it becomes negative or positively charged. So here we have an idea, an example of rubbing 2 objects together. We have maybe a cotton or wool cloth. We're going to rub it onto a rod. And what you see is we have a transfer of not protons, but electrons. The cloth in this case has lost electrons. Where did they go? They went onto the rod. The rod gained those electrons. So we have a loss, which means we have fewer electrons. So it's a net positive, and here we have a gain, a surplus of electrons. It's net negative. When it comes to moving electrons, we often do something called grounding. When you ground an object, you're basically allowing electrons to either leave or to enter. Literally from the ground. And so if you allow them to leave, right, you're going to lose electrons, and allow them to enter, you're going to gain electrons. Only electrons move. Why would they move? Well, very simply, because we know our fundamental rule at opposite charges attract. So electrons might be pulled to something that's net positive. So they're going to enter, or they might run away because it's net negative. So they want to get away from each other. Now when we transfer charge, you have to remember that charge is conserved. And we know conserved means things are not created or destroyed, they just move around. You end up with exactly what you start out with. And so it's our belief that the universe is a closed system. There's the same amount of electrons now as there always were. We can simply move them around. Lastly, why do things conduct these electrons, and why won't they conduct electrons? Notice I didn't say protons, because only electrons move. Well, conductors, and typically we think of these as metals, they don't hold on to their electrons very well. They allow them very easily to move. So electrons can quite literally travel from one side of an object to the other side. But when it comes to an insulator, and we think of rubber, plastic, glass, things like that, the electrons can't leave their atom. They have to stay tied in to their atom. They might be pushed to the other side of the atom, but they can't leave the atom, as with a conductor. A conductor, there could be an atom up at the top of this object, and an electron will run to a different atom someplace else.